Bless you. All right, so here we go. It says, in baseball, home plate is a pentagon and the dimensions of home plate are shown. What is the sum of the measure? They're not asking for each angle, right? So can't we just look at that and say 540? Because why? Yeah, it's just n minus 2 times 180. Now, I'm not even sure we could calculate the other angles, right? I mean, we could obviously say this is probably a right angle, but I don't think we can figure out the other angles. Okay? Now, tell me what else you said? The bottom three here? Okay, so it says find the measure of the exterior angle. So someone tell me what the sum of the exterior angles are. Tell me.
Side.
No, the sum of the exterior angles.
Oh, I see.
They're always 360. Thank you. They're always 360 degrees. Do you agree with that? Now, here's the key you have to understand. Here, make sure you see this. Regular. Since it's regular, what's true about all the angles? They're equal. Does that make sense now? So the answer is just 360 divided by n is equal to the exterior angle. Does that make sense now? So that's easy. 360 divided by 7, 360 divided by 13, and 14. All right, come on, guys. Anybody else with an issue over the homework? Anybody else? Anybody else? Good for you, Bo.
31.
All right, let's look at 31. Good job. So again, all of these angles add up to what?
That's why I didn't know.
You with me? That's all right. Now you know. Exterior angles are always 360 degrees.
Okay.
All right, so just adding the x's. How many x's? 1, 2, 3, 4, right? So I have 4x. This is minus 30. That's 29. So what is that? 20, 62, 76. Does anybody else get that? Plus 76 equals 360, right? And somebody who's been telling me, what could I do to make it easier? Just divide by what first? Yeah, divide by 4. So x plus what? 19 equals 90. So x was equal to 90 minus 10 minus 9. What is that? 71. Everybody happy with that? Come on now, anybody else have any questions? Everybody's good. Remember, I think the key is just make sure you're doing the problems, doing the work. I don't think it's that hard. All right, let's pull up today, which is section 6-2. And what I did was I copied the page, and then I just spread everything out for you. And then I wrote down the statements and reasons. We're going to do a couple proofs today. All right, it's not difficult. Today, though, we are going to talk about a parallelogram. All right, so someone tell me, what do you think a parallelogram means? Or what is the definition of parallelogram? Say it again. Opposite sides are what? And it must be called a, how many sides? How many sides? 4. So it's a quadrilateral that has opposite sides that are parallel. All right, so let's review this. All right, so that I will call a parallelogram. All right, so there's my parallelogram. So from that, come on now, guys, everybody's got to watch real quick. We're going to say that this is parallel and this is what? Parallel. So what else do I know about the parallelogram? Right. Well, because it's a parallelogram, let's talk about this. Because it's a parallelogram, somebody tell me what's true about this angle right here and this angle right here. They are supplementary. So come on now, listen, if you pay attention now, you won't have to remember all the rules. All right, because there's a whole bunch of rules that go with parallelograms. And I'm telling you, if you understand what a parallelogram is, I can list out the rules without knowing any of them. All right, so that's why I want you to really concentrate with me. Make sure you're with me. All right, so I'm just going to say for my own benefit, this is angle 1, this is angle 2. Those add up to what? What about angle 2 and 3? What about angles 3 and 4? They add up to 180, right? And what about 1 and 4? So because of that, someone tell me what's true about angle 2 and 4. They're congruent, right? And what about 1 and 3? They're congruent. And that had to do with that. Supplements of congruent angles are congruent. Is everybody good on that? 2 is supplementary to 1. 2 is supplementary to 3. Therefore, 1 and 3 are equal. All right, so just based off of that, I've just proven to you that angle 2 is equal to angle 4, and angle 1 is, and angle 1 is congruent to angle 3. All right, so now what's true about the opposite sides? Well, how do I know that? You can't just look at it and say that's true. Because why? That's why I'm asking. We can't just say because Bo knows. What? You're talking about angles. I'm talking about sides. Listen to Mr. Stauffer. He knows. So just because sides are parallel, they're congruent. So here's a line that's parallel to this. Are they congruent? No. Uh-oh, it's because it's what? Come on. Oh, here we go. Very good. She said, draw the diagonal in. All right. And if you draw the diagonal, all right, now what do we know? What's true about this angle right here and this angle right here? They are congruent. That is correct. And what is true about maybe this angle right here and this angle right here? They are congruent. They are alternate interior angles. And then what's true about this side? It's equal to itself. So those two triangles are now congruent by what? Angle side angle. That is correct. The triangles are now congruent by angle side angle. So now we can say boldly that this is equal to this, and this side over here is equal to this side over here. Is everybody good with that now? All right, so far in a parallelogram, we are saying that opposite sides are congruent. We are saying that opposite angles are congruent. All right, now I'm going to draw this. Thank you, by the way. Here we go. Let's do this. Let's draw this right here, from here to here. Are the diagonals congruent? Definitely not. The diagonals are definitely not congruent. You could be able to look at that and say, one is tilted. So the obtuse angle is creating a longer diagonal than the acute angle. Does everybody agree with that? All right, so they are not congruent. All right, but what's true about, let's look at this guy right here. What's true about this angle right here and this angle right here? Does everybody agree? Those are equal, right? Now, what I really want to focus now on is this, guys. I'm going to erase a little bit here. And I want to concentrate on the top triangle and the bottom triangle. What looks to be true about the top triangle and the bottom triangle? They look equal. I'm not saying they are yet. And what about the two triangles on the side? Hey, come on, come on. What's true about the top triangle and the side triangles? They're equal, but we still have to prove it, right? And so once you're able to prove it, then you can say everything you want to say about all the information of a parallelogram. So I still want everybody to agree with me that this angle right here is equal to this angle, right? And you just told me that this angle is equal to this angle. And then we have the opposite sides were what? So this guy is equal to this guy. Do you agree? So now, did we prove the triangles are equal? Do we agree with that? Does everybody agree? Triangles are equal, right? So what's true about this and this right here? They're definitely equal because they are what? CPCTC. Does everybody agree? All right. Now, do you agree I could do the same thing with the triangles on the left and right? So what's true about this right here and this right here? They are what? They're congruent also by, again, same thing, CPCTC, right? So now what's true about, who can tell me what's true about the diagonals of a parallelogram? What do? They bisect what? They bisect each other. They bisect each other. Look up there real quick and see if you understand what I'm saying. Right? If this, come on now, this is where I need you to understand. This right here is a segment, and I cut it into two congruent parts. That's a what? That's been bisected. Same thing with the other side. This over here has been bisected, correct? Because it's been cut into two congruent parts. So the diagonals of a quadrilateral bisect each other. So what exactly does that mean? If I said this is 5 right here, then the other side would be what? 5. And if I said this was 6, then the other side would be what? All right. So to me, when I first learned geometry, my teacher listed all these rules about the parallelogram. I was like, there is just no way I'm going to be able to do all that. Right? There's too much information. All right. But I learned you can easily come up with all of that information. It's easy to tell me what's true and not true about a parallelogram if you just understand that it's called a what? It's called a parallelogram. And we just did all the proofs to the chapter basically just now. All right. Just because we know that a parallelogram, the opposite sides of a quadrilateral are parallel. That's the definition of a parallelogram. So if I say the shape is a parallelogram, all of those things that we said were true. All right. And I want to review them. And if you want to write them down, you can. It's not necessary, I don't feel like. All right. Because again, I can just walk you through it again. All right. And that's something I want you to be able to do. Draw yourself a parallelogram and then tell me everything you know about the parallelogram. So parallelogram, opposite sides are what? Opposite sides are parallel, and they are also what? Congruent. All right. Parallelogram, opposite sides are parallel and congruent. What about opposite angles? They are what? They are congruent. And then the diagonals, they bisect each other. Are the diagonals equal? No, that's the most common mistake kids make. All right, they think the diagonals are equal. And then consecutive angles are also what? Supplementary. That is exactly correct. All right, I just feel like that's pretty easy. All right, so here we go. Let's take a look now. Number 1, it says, if angle NMQ is 32, so here we go. This is 32. What's MNP? Right, I'm doing letter A, right, guys? And what? 148. Is everybody okay with that? 148 degrees. Now, we're going to say that angle MQP is 125. So if MQP is 125, if that's 125, then what's MNP?
125.
Yeah, jump in. I don't care. 125 degrees. Beautiful. And if MQ is 4, then NP is what?
4.
I told you guys, super duper easy. Super easy. And this is what I'm saying about this whole chapter. The whole chapter is what? Super easy. All right? Again, participate though. All right? Don't let me do all the work. All right, here we go. Number 2, find each variable. So,
X equals 38.
well, how did we get that?
Because 2 times 38 is 75, but then 76 minus 1 is 75.
Yes, so he did 2x minus 1 equals 75. Beautiful. Right, you could also incorporate these two, add up to 180. You get the same answer. All right, and then we can just do our mental math and say x is equal to 38. Any issues? All right. Charlie, you all right? You have an iPad today? Oh, it's charging? Okay, all right, I'm all right with that. I just want to make sure. All right, here we go. Number 3, obviously, y equals what?
15.
15. Right, come on, guys. Everybody, tell me. All right, number 4, what do we have? What's the relationship? I really only care about an equation. Does everybody understand? I don't care about solving it. These are basic. All right, somebody tell me what a minus 7 equals. A minus 7 equals 2. And then what?
Equals 9.
No, I don't care about that. What's the other equation? 2b minus 6 equals what?
10.
Yeah, I don't care about solving that. That's like my little pre-algebra kids can do that. All right, number 5. What do we got? And then? Right. Here we go. That's perfect. All right. Now, this is something I never understood about kids. Let's look at this guy right here. This right here is the midpoint of this. Does everybody agree with this? And this is the midpoint of this. Do you agree? So that is the midpoint of what? Of both of them, correct? And for some reason, that's difficult. I never really understood why. All right, bisect means they cut them in half, right? So if they cut it in half, that's the midpoint. Does everybody agree with that? So now when we come down here, do something like this, let's draw A, B, C, D. So -4, 6, 5, 6, 4, -2, -5, -2. And now when we draw this, And if I call this A, B, C, D, and notice when you name a parallelogram, you always go in clockwise or what? Counterclockwise. Everybody agree with me? You're not saying A, B, and then C, D. You're going in clockwise or counterclockwise as you name them. All right, so if I want to find the intersection of the diagonal, the intersection is just the what? Yeah, but what? How do I find it? Yeah, if you draw the diagonals, I'm not going to argue with you, but I don't really think I need to draw the diagonals. What can I do to find where they intersect? What do I do? I tried to tell you earlier up here. This is the what? That's the midpoint. The intersection is the midpoint, right? So what's the midpoint of AC? Oh, come on, man. Midpoint. What's the, tell me. 0, 0, 2, right? How is it 0, 2? Right, the midpoint. Come on, midpoint. Remember, I want you to remember midpoint is an average. Wow, some of you guys, we blew that. Midpoint. Everyone write down x1 plus y1. I'm sorry, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. That is the what? That is the midpoint formula. Come on, we need to know that. That's the midpoint formula. So what's going to happen if I take the midpoint of BD? It's going to be the same thing, right? So I need you to make sure you know that. All right. All right, let's continue on. All right, let's see. We got a couple little proofs here. All right. Now it says write an indirect proof. Do we do that? No. We write a 2-column proof. All right. So what do you think this symbol is right here? Yeah. Given ABCD is a parallelogram, and angle A is a right angle. I want to prove that A, B, C, and D are right angles. All right, so let's go ahead and do this. Number 1. All right, here's what we have. All right, here we go. What? And this one says given. Now, I need to prove that angle B, C, and D are right angles. Someone fill me in. Well, we already know that angle A is congruent to angle D. Why is that?
Alternate.
No, 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 no. Someone tell me opposite angles. Yeah, opposite angles of a parallelogram are congruent. All right, so now we know that D is the right angle. Tell me. I would prefer, yeah, I know exactly what you mean. You're right. But what? Say it again. I'm sorry, I can't hear you. This thing's so loud. Why is that? Is this the Bo rule? I know you're right. You're right, but I want a reason. I want a reason. Tell me, or tell me what you think. Shh. Yeah, A is supplementary to C. I like that. All right. So angle A is supplementary to C, and what? Well, wait a minute. I know A is supplementary to C, and C is, go ahead, continue on. What were you saying? I don't want to mess you up. Yeah, that's one way to do it, 100%. You can say that step 4, we can say that angle A plus angle C equals 180 degrees. All right, this we can say consecutive sides or consecutive angles are supplementary, right? And then angle A plus angle C equal 180. That's the definition of supplementary. And then we can say angle A is how many degrees? 90 plus angle C is equal to 180. And so that would be what? Yeah, we could substitute in there. And then we would say angle C equals 90 degrees. That was subtraction property. And then angle C is a right angle. And that's definition of right angle. So now we have A, C, and D are right angles. And then step 8, what? Angle C is congruent to angle B. Yeah, opposite angles are congruent. Opposite angles of a parallelogram are congruent. Is that the only way to do this? No, that's not the only way. That is a good way, but not the only way. All right. Any questions? All right, let's try number 8 since it's been a while. All right, here we go. It says, given those are parallelograms, an angle A, or we're trying to prove angle A is congruent to angle F. All right, so let's do this. Number 1, we're at given. All right, people. I'm trying to prove angle A is congruent to angle F. Thank you. Tell me what? Say it again. BC. You're awesome. Here we go. That's a good job. So angle BCH is congruent to angle GCD. That is a vertical angle theorem. So I'm going to mark that. Okay. Someone else, or continue on. I'm liking that. Yes. Angle BAH is congruent to angle BCH. And again, that's a good job. Opposite angles of parallelogram are congruent. And now what? Say it again. Yes. Angle DCG is congruent to angle GFD. Isn't that the same reason, right? So now what? Yeah, we could have just said angle A now is congruent to angle F. And we can say that's just substitution, right? All right, that was a good job, kiddo. Nice, right? Not too hard, guys. Not too hard. Yeah, I'm listening. I'm supposed to care, I know, but guess what? What's up with that? All right, do you guys check to make sure it's working? All right, so do me a favor. If you want, if you think you understand what we're doing, you can run to Miss Hill and say, we need some new chords in here. They're all frayed and broken. Right? The chords are bad, right? Yeah, ask her if she's got more chords for us. Tell them we could use 10. Yeah, because I mean, those need to be filled up. There's some over there that are bad. Hurry up. All right, here we go. So this should be easy. Angle R, somebody tell me.
52.
Thank you, 52. Oh, hey, Brady, I've been dying.
Yeah.
I've been dying to give you your picture back, man. Wait, where? I'm trying to show it to you. Do you see it?
Yeah.
You look so good, man.
Thank you.
All right. Today is retakes.
Okay.
I'm just saying, man, if you want to make it in, it might not be a bad idea. This picture looks a little old, man. All right, here we go. So what's QR?
3.
3, brilliant. QP.
5.
Let's try giving a right answer today. Angle S.
128.
Wow, we are brilliant. All right, here we go. Scroll down. All right, again, these are all the rules here. All right. So B equals what?
What in the world?
B equals 11, right?
Oh.
So again, we're trying to work on our mental math. A equals what?
7.
Equals 7, brilliant. 16, Y equals 101 and X equals, all right,
79.
hold on. All right, here we go. Okay, guys, I think that's good enough for me today. The rest of it's easy. All right, you guys got this. All right, flip through it, please. Make sure you get it done. All right, you got some time. All right, get busy. Get it all taken care of. Yes. Oh, which one is that? 17. I think Y minus 10 or Y minus 7 equals 10. Yeah. All right, my homeschool peeps. Everybody doing okay? Everybody understand everything?
Yeah.
All right, guys. You guys have a good rest of the day, man.
Thank you.
All right, take care.
Thank you.
Stay
Have a good
well,
day.
everybody.
Thank
Stay
you.
well. Hope to see you guys soon. What do you think? Yeah, for you.
Yes, for me, all you guys have homework.